together on this because I think search problem is fairly tough and everyone has their own sort of perspective. And today I'm going to be focusing on neural search. So this is not something you worked on. I guess you're working more like on the text search, right? Neural search is closer to deep learning and something that has been brewing there in mathematics world for quite a while. But I would say maybe since 2017, this became possible that we can merge deep learning and search together. Have you heard of this before? Cool, so maybe this will be something new. PhD in natural language processing, actually more like mathematics, but I worked on machine translation back when it was like statistics, not deep learning. And I've been focusing on search engines for about 16 years in various capacity, also academic as well as startup, and also build search engines like on web scale. So think of Google, but not exactly Google scale, but something that we kind of aspire to become. During COVID, I just didn't find anything better to do in my free time to focus on vector search. This is something that has been emerging and caught my eye. You know, and actually, like a year after I started doing this, I also launched a podcast on YouTube and also on Spotify. So if you like listening to podcasts, you can also check it out. Yeah, so and I've been also sharing some practical recipes how to get going about vector search on your own using open source components or maybe building a bit of your code. So the first thing, let's start together on this. I know it's like an icebreaker, so bear with me. I know it's early morning, also for me, but I was wondering, like, if some kind of criteria which is personal to you, what makes a search engine good for you? Like, if you think of all search engines that you've used, maybe you can also tell me which search engines you are using. And also, like, what works, what doesn't work, what you think should work better?
Well, I use Google Capital and Google Capital. And the thing, if I compare that to Google, I use Capital primarily because it gives me search results based on what I actually search. And Google, like, if I have a really technical niche problem that probably can be brought to me like based on my previous searches.
Like your history, right?
Yeah.
So you think Google works better for technical queries, but DuckDuckGo works.
Like if it's a niche query, like I think one person has asked the same question. And
Right.
I probably use Google.
Okay.
If you say like I'm looking for documentation.
Yeah.
Or general searches.
Okay, sounds good. So, and so why do you use DuckDuckGo and not always Google, or vice versa?
Well, I kind of like the fact that it's not personalized to me, and I also don't know that it's not tracking me, which is what I don't like in Google. But
okay.
like I know it, like if like the top of us the same query,
yeah,
the same results.
Yeah. Okay, so you value privacy, right? If I can summarize, and the fact that you are not showing ads, being shown ads, right? Go ahead.
I expect forming queries to be intuitive. I use Google, and I have a pretty good feeling of how I should type out my queries to get the results I want.
Yeah.
So, I expect formulating queries to be intuitive. I think that's also to do with how much you use a certain engine. You see what kind of structures work.
Yeah. And so by intuitive, do you mean like natural language, like the way you think, or?
More or less, yeah.
So like you would say that Google trained us in a way to type keywords and not actually kind of a question, right? Or
Yeah,
a
yeah.
query.
I always use keywords.
Yeah, yeah.
And it works very well.
Yeah, that's a good point. Thank you. Please.
I actually use Google more like a ask use sort of search engine. Ask question. If I have a question to ask, I
Yeah.
ask Google.
Okay.
And if I like that keywords, then I probably type it code.
Yeah.
Because like Google is like better at this.
Yes.
It's quite advanced, I think.
Sure. Yeah. Actually, while we're on this, do you guys know this website? Let's see if it loads. Search engine map. What it does is that it actually tells us the yellow dots are the search engines that create their own index. So they essentially crawl the web and they own the data. The green dots are the search engines that use the yellow dots. So they do not crawl their own data because it's hard. It's a really hard problem. Like if you write a crawler today, most likely it will be blocked by majority of websites because they will say, we trust Google, we trust Bing, we know Yandex, that's it, right? And so you said DuckDuckGo, I think it's here. And do you guys see this or is it too small?
I think it uses Yandex and Bing mode.
Yeah. This map might be a little bit outdated. I recently heard that DuckDuckGo switched to Google, but again, this just tells you that even though DuckDuckGo doesn't capture your history, they could, but they don't, right?
Yeah.
But they still send it to Bing. And so Bing could actually do some tricks. For instance, they could take your IP address and associate it with you in principle. Of course, if you use some VPN, maybe that's harder, but in general, for an average user, you probably wouldn't do it. And so in principle, they could learn some of your tastes, but they don't, like DuckDuckGo doesn't use it against you.
Yeah.
But Bing kind of augments their data, right? Let's say for training models or, you know, showing better ads and so on. So just for information.
Yeah.
Go ahead.
Why is Bing so popular as a source of data? Is that Google doesn't want Google to share theirs, or
so that's a really great question. I think the reason is that Google dominates the market. So they're like 97% across the whole web, everywhere, except few countries like Korea, Russia, maybe like Czech Republic. I think they have own search engine. But and so they don't need to collaborate with anyone, you know, like they have plenty of money in that sense. But recently there was actually a development that Google loses their position, especially in the US. So like people started to use it as a navigational search engine to land on some other website. Yeah. And Bing, however, is like 2% of search traffic globally, right? And so they want to promote their search engine as much as possible, right? And so that's why they collaborate with a number of derivative search engines, you could say. Some of which are really cool, like a Cosia, I think. Raul knows what is that. It's just mentioned, but I don't know if it's still online. Yeah, okay, but let's go back to our exercise. Anything else? Like, I really love the formulated queries should be intuitive, and maybe we could say natural language, right? Or like, I don't know how we can actually properly formulate, but kind of like, I should not be constrained with what search engine expects of me, more like what I want of the search engine, right? Yep. Anything else? Anybody else?
I find it really annoying when Google overcorrects my search. So like
overcorrects.
Yeah, if I search a query and I know what I meant, and then it still like it says like, did you mean? And I'm like, no, I didn't mean.
Okay.
That meant what I said.
Yeah.
So I think correction is a good feature, but there's the possibility of overcorrection.
Yes. What do you do in that case? Like, did you have any tools to kind of?
I guess it gives you the option to still go back to what we meant, but it's annoying to have to like
to kind of extra click.
No, this is what I meant.
Yeah, exactly. I agree. In some cases, you can use double quotes, but that means you are doing a phrasal search, and sometimes maybe it's too restrictive. But that's a good point. Like basically we're talking here about, in some sense, UX, right? User experience. It's not as smooth as it used to be, because Google actually is a advertising company. And so 97% of their revenue comes from ads. And so they, if you've noticed that they started showing more ads at the top, and that's the reason, like they are advertising company. They are not a search engine company per se, but yeah. Please go ahead.
I was doing last one ontology project for one city, and they are removing their websites, and they wanted the like index of things, like it was really so intuitive to use that the people who are searching things there are finding things that you didn't know they needed, but they just stumbled upon them. So that's a feature I like appreciate in a search engine, and provide me some things like I didn't already know I needed. Some information.
So it's like, I think it's called, if we consider search engine as a recommender system, in some sense, it's like an explorative recommendation. So like not based on your history, but just, you know, injecting a random result and see how you react to it. Yeah. So I guess maybe we can formulate this as discovery. Would you agree? So it's like, instead of going in the circle, you can also discover new content. And I think this is where search blends with recommenders. Actually, this is really good point and topic, especially in the context of neural search. Any other ideas, or like something that annoys you in search today? And maybe, do you use any other search engine than Google, sort of like, I don't know, Netflix or university search or library search, something that you use periodically and you think it could be better? Anybody?
Alma.
What?
Alma, the old university internet. I think Llama is still a reskin of that database. So
Okay.
waiting for Llama 2.0 to come out, but it's horrendous.
Yeah.
I once searched for Japanese courses, like the responsible teacher, and I typed in Japanese basics responsible teacher. You couldn't, like nothing. And then I typed it into Google, like Helsinki University, is like the first result.
Yes.
So,
yes, exactly. Do you know, by the way, why Google fundamentally is better than, let's say, if we now today decide to build a search engine, we will probably be inferior for some time. So why do you think Google is better? What makes it better?
They have more data.
Yeah. What kind of data? What do you think?
All kinds, I don't know.
Like web pages or
Um,
something else?
I suppose, and then previous searches.
Yeah. User
have
searches.
a good idea of what kind of things people look for, what kind of search results people end up clicking on.
Yes.
How people form their queries.
That's really good point. So it's like queries, clicks tell us whether or not this was relevant, sort of measure of relevancy. We don't know exactly if it was relevant, but Google is able to track if you ever come back. So like if you clicked and went away, there are two chances. Either you are satisfied or you're just distracted. So, and they can measure it like on aggregate, on statistical level. They could say, yeah, we think that if we divide all queries, you know, head of this is probably relevant with all the clicks on the first page, and the tail, it's like individual cases which might work or don't work, but they don't care. Like they do optimize, but don't care. So
they're good because they had a lot of time to ask themselves the question, what do people expect of search as a user?
Yeah. And they can actually also do this type of head thing, right? So when you type a query, they actually show you suggestions. And these suggestions are based on somebody searching before you in a similar context, geography, or wherever. Yeah. Cool. All right. Maybe we can keep going. And I think we could, if time permits, we can come back to this slide and just think after a couple of demos that I want to show you as well, what else would be nice to have. So this is just really like a sort of, let me launch this, I'm sorry. So what is neural search? Why neural search? Why we cannot survive with text search? Use TF-IDF, inverted index, bag of words approach. So I think the main problem, and I don't know if you've noticed already in your search engine development, is that bag of words, of course, doesn't care about context, right? So it's like, if it's bag of words, if I take my text, if I split it to individual words, so they lost their position. Of course, we can record the position of the words, but that doesn't tell us, why this word precedes this one, what it actually means, right? And so there was this famous paper, Attention is All You Need. And you've probably heard of BERT model, right? No? So BERT model is essentially trying to capture the semantics of texts on some level. And the way it does it in a layman terms is that it takes the text, it masks some words in a sentence, and then it asks the model to predict which words are there, right? Mm-hmm. And if it makes a mistake, it basically receives, like in a neural network, receives like this backpropagation where it says you need to correct your weights to predict these words better next time. And it is trained on a large collection of texts. Let's say you take Wikipedia and you can train, and it's like many, many millions of articles there. So, and if you build your search engine today using TF-IDF approach, if you would represent your document in a way that, the first word, let's say alphabetically, right? If it's there, it's 1. If it's not there, it's 0. So it's going to be like a binary vector like this. And it's also very sparse. By sparse, I mean that there are a lot of zeros there because documents comparatively do not contain billions of words that you encounter in your collection, right? And so there will be very few ones, and then the rest are zeros. And essentially then in TF-IDF, as far as I understood, you have covered that material. You essentially compute an angle, right, between the query and the document. And it's like a cosine similarity, right? And in addition to TF-IDF, there is also BM25. You don't need to worry about it. It's sort of like a modification of TF-IDF, which tries to make search a little bit better, like the ranking a little bit better, because there is a problem of so-called term saturation. So if you have like 2 terms that occur very frequently in your collection, at some point, it's really hard to distinguish between them using TF-IDF. And so BM25 accounts for that. And it's a standard de facto at the moment. So if you pick like an open source search engine like Elasticsearch, I don't know if you heard of it, you won't have this one as default. You will have BM25 as default because it actually is better. Not for everything, but on average. But if you want to search in images or audio or video, you cannot use TF-IDF, right? Because there are no words there. And I don't know if you encountered search in images or audio, how prevalent is it? But actually today you can do that already. And I will show you how. Or like I will show you a couple of demos. And what's interesting also with deep learning recently, you are able to search images with textual queries. And those queries will be in natural language. So I don't need to type keywords. I can actually ask a question. Okay. Does this make sense? Why and how is this different? Cool. And I also did like a really quick and crappy Google Trends comparison because I think people don't search inverted search, but let's imagine they do. So just ignore this part. I don't know what's going on there. But like lately, neural search has been catching up. And that's because there is a lot of interest in this. And also there are production-ready neural search databases as companies and open source products that are becoming popular today. Cool. So what's a vector? Sorry, this formatting is a bit off, but So essentially what happens is that if you apply a deep learning model like BERT onto your text, then you will have concepts, let's say like here, newspaper, magazine, and article. And let's imagine that our model produces three-dimensional vector, which it doesn't. It produces like 768 dimensions or whatever you choose. It's like super, super big. But just for the sake of visualizing it, these concepts are related. And so geometrically, they are together in the space. Okay? And apple and banana, they're like fruit. They're also together. And this is like very important property because if I have a query like I'm searching for a newspaper, I don't know, New York Times magazine or whatever. So the search will not go here, it will go here, but it will not go exactly at the first go. The data structures allow us to gradually get there. And this is called approximate nearest neighbor search. Because like if you have billions of these points, it's impossible to traverse them for every query, right? Because it will be way too slow. Okay, cool. Any questions on this? Hopefully this is kind of clear, right? Right? Cool. Now let's do some demos and let's work on this together as well. So the first one that I wanted to show you is image similarity demo. And so just to show you what similarity means, right? So what I did is that I've uploaded an image which I think doesn't show here anymore. I think it looks like this. Okay. And I asked the search engine to find me similar pictures, right? And the way this works is that it takes my image, it computes a vector. In this case, it's using a clip model. And this model produces 512 dimension vector, fairly big. And then it basically matches the index, right? And as you can see, many of these look quite relevant, right? Would you agree? But on top of this, we can actually ask questions. So here I type blue shirt, and for some reason picked like male blue shirt. I don't know why. Does anybody know what this is called? Like I didn't tell the search engine if I'm looking for male or female, and it picked male.
I don't know why, but if I had to guess,
yeah,
I assume the word shirt, like
yeah,
shirt means more like a dress shirt.
yeah.
That might be more like connotations might be more male.
Right. Okay.
Probably like
Mm-hmm.
T-shirt, you might
Yeah.
get better.
Yeah. But I think this is called bias, right? So so the search engine is biased for some reason to male shirts. Maybe it has more male shirts. So like even if I scroll down, like I don't find any female shirts. So let's see if I type female here. Okay, so there are female blue shirts, but for some reason the search engine decided to bias towards male. And what does it tell us of the deep learning model there, or maybe of the data that it was trained on?
What happens with different colors?
Yes, absolutely.
Ooh, red. Can you find people of color?
Oh, give me the query. So people of color.
No, but you also bias towards the skin color. Right?
Yes, yes, but like give me a query and I will type it. But let's type yellow shirt. I wanted to show you something. So some of these are yellow. I don't even know if they're shirts always, but maybe this is a hoodie, I guess. But what caught my eye here is there's like a yellow car, and I was like, wow. So I think the model, the way deep learning model works, and I did mention that title, attention is all you need. That's the paper. It's based on attention, and we don't need to go there, like explaining what it means. But roughly, the neural network chooses to focus on certain features in the image, right? And a collection of images influences each other. And so for some reason, neural network decided to focus on this. Maybe there is like a shape as well. Like if this was focusing not rear, but kind of like the profile of the car, maybe it wouldn't pick it, right? But it did pick it here, thinking it's a shirt. But there is also a man there with the shirt. So maybe it thinks, okay, they are somehow semantically related. So I might as well just say this is a shirt and I don't care if it's not yellow, but it's kind of yellow is there. So what do you want? Okay. Anything else?
Red shirt.
Red shirt. Sure. Yes, sir. Let's see. Oh, wow. So what happened here? What do you think? Why model decided to pick these postcards? So I don't know what are they. So what happens is that yeah, it's a clip model. It's a clip model. It's yeah, just trained on all the images out there. So I think what happened here is that actually this clip model, the way it's trained is that it's a kind of like two-tower network. So it has the caption, which is a text, and it has the image. And if you have like billions of these, at some point they will merge and influence each other. And so it will learn, it can also do OCR, optical character recognition in some sense. So it actually knows this is a word and this is two words, right? You can also ask it to generate the text out of the image. So here, that's exactly what happened. So I guess you're not exactly satisfied, or do you like this result? You do get this image though. Any other queries? So you want to stay on short? All right, sure. That's interesting. Green. Oh, maybe I should say short. Let's see. Yeah, maybe this one, this one.
No, the Irish emo boss was also in the yellow shirt. So.
Yep.
Could it be that blue shirts are just more prevalent in stock imagery?
That's possible. That's absolutely possible. By the way, the way these images got collected is that there is a project called Common Crawl, and so they crawl the web and they give these web pages to you. And what happened is that this specific project, Leon, they picked all the images from this data set. They removed all sort of, not appropriate images. And they also removed images that don't correlate with the text. So you can actually compute a vector on the text and compute vector on the image, compute the distance. And if it's less than 0.3, they drop it. All right. Yes, it does. So basically, let's actually do this thing. So red shirt was not satisfactory, right? Here, I can actually choose to search in the text. Okay. So what happened here is that instead of looking at the, features of the image, it looks at the features of the text, and it finds a much more relevant result, right? Sure, go ahead.
Which textual content of search engine can you use to find the images? Is it the metadata, the captions, or just all text that appears on the same page as the same time?
It's just the captions. So it's like, yeah, it's like if they happen to parse it out from the web page, if it's present there, then they took it. And so you can see it here, right? Red shirt guy, man, red shirt, and so on. Any questions that you can ask? Like, we can ask some question to this. I mean, like, this will not be a question, but this is like a particular Jeep with like big wheels. And let's try image, because as you can see, text does give us something, but also gives us yeah, it thinks like we are still on the short topic. But with the image search, it gives me what I'm looking for, right? But if I remove this part here, so I'm saying just red Jeep, let's see what happens. Kind of starts to give me sort of generic Jeeps, but not necessarily with big wheels. Okay, cool. Let's move to the next one. How did you like experience of this search engine? Would you use it? No? What you didn't like?
The image search seems quite unrefined so far, or it's really not managing that well at this point in time. It's really misinterpreting things in pictures, which tells me that it's not really, ready to take
Feels like a little bit random, right? So it's like, so maybe it would be nice to have some filters here as well. Yeah, go ahead.
What kind of textual data do other larger search engines use to match pictures with queries? Do they also use like other text on the pages?
Yeah, they do, and it's not just the text. So if you look at Google ranking formula, it might be like 100 megabyte. If you print it, it's like super big. So because they have so many signals, and sometimes they are not even textual. It's like clicks, time. They also predict your gender. They predict some of your taste. They have your history if you're logged in, right? Or if you have cookies and so on. And so there could be thousands of parameters that they actually look at, some of which are text, some of which are probably image features, and the rest is just numbers that they got from interaction. Yeah, and that's why they're like, if they only looked at text and only looked at image, their search would be like beyond, like below mediocre. Like nobody would use them, unfortunately. So unfortunately, you need more than just text.
Would it be possible for the engine to show the error, like the value of the error function for all the images, so you see like?
You mean value of what? Of distance,
like,
or?
When the model like it gives some error function, like which is some value.
Actually, what it does here, and I take this display similarities, right? Okay. So a perfect similarity would be, I'm sorry, this is a little bit too small, maybe. A perfect similarity would be like 1, right? Between 0 and 1. Here you can see that it brings me 0.35. So it's not as good actually. But if I type like blue short, let's see what happens. It's not as good either, but it's like visually, well, forgetting for a moment that it's biased, it's a good result in some sense. And I'm not very specific in this query. So I'm just saying, give me all blue shorts, right? So it's not necessarily an error. You can say if it's below 0.3, then maybe it's not a good result. And you could actually even drop it, right? You could show it to the user, but you could also say, this is not good. Let's not show it. Yeah.
I recommend mostly for like learning purposes.
Yeah. It's actually hard to collect this feedback from the users, but you can try to do it. Maybe even indirectly. Like if they didn't click on this first page and they kept scrolling, it means that your ranker is not good enough. So maybe you can kind of look at the image that they did click and then feed it back to the model, to actually re-rank this. Yeah, that's a good point.